Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discuss about another method, that is solutions to system of non-linear equations. Okay, so far we discussed that equations for one variable. Okay, solutions for one variable equations. Now we are going to discussing about solutions for non-linear equations. Those non-linear equations exist in the system format. Here system is nothing but whenever you have equations more than one. Okay, if you have two equations, three equations in a problem, then those equations are called system of equations. Okay, when you face the word system, definitely there exist at least two equations, okay, in different variables or either one variable. Now we are going to discussing about system of equations in different variables. Okay, so therefore the first method, in this method we have two methods, the method of iteration and the falsification method. Okay, so therefore the first method is method of iteration. So by using the method of iteration, we have to find the root of the system, find a real root of the equations y square minus 5y plus 4 is equal to 0. That is the first equation, and the second equation is 3yx square minus 10x plus 7 is equal to 0 using the iteration method. Okay, so by using the method of iteration method previously we discussed. Okay, so that is different and this method of iteration is different. This is for non-linear equation, that is linear equation in one variable. This is non-linear equation in 2-3 variables. Okay, so therefore see the solution. Given system of non-linear equation, we can take it as equation number 1. Okay, so that total two equations we can take it as equation number 1. Clearly x equal to 1 and y equal to 1, pair of x comma y is equal to 1 comma 1. Okay, if you substitute in equation number 1 x is equal to 1 and y is equal to 1, both equations will equal to 0. Okay, clearly we can say that x comma y is equal to 1 comma 1 is the equation of system of equations 1. So now you know very well x is equal to 1, y is equal to 1 is the root of the given system. Now, so by using the iteration method, so now we are going to derive that the convergence of these two systems. Okay, so therefore that is to apply the iteration method, we are going to rewrite the system of equations 1. So therefore that is, so basically what is the iteration method, what we discussed in the previous method is, so first of all they will give one equation f of x is equal to, okay, f of x, then we have to take it as that f of x is equal to 0. After taking f of x is equal to 0, you have to convert that equation as x is equal to pi of x. They will give one equation in the format of f of x, either it is algebraic or transcendental. That equation we have to consider as f of x is equal to 0, and after consideration you have to rewrite that equation as x is equal to pi of x. Okay, after writing x is equal to pi of x, we have to take the convergence condition for the convergence, that is we have to derive the value pi dash of x, magnitude of the derivative of the given pi of x is less than 1 at interval a comma b. Okay, at interval a comma b, where what is the interval a comma b? That interval gives the initial approximation. Okay, where a and b are the initial approximations, and if you substitute a and b, that function gets the opposite signs. So after getting this condition mod pi dash of x less than 1, then you can say that we can apply the iteration, the approximation root exists. So after getting this value, you can write that x suffix n plus 1 is equal to pi of xn is the iteration formula. Okay, in the iteration method, x suffix n plus 1 is equal to pi of xn. Pi of xn is the formula for the iteration method, where n is equal to 0, 1, 2, 3. N is equal to 0, 1, 2 up to so on. So that is the original iteration method we discussed in the previously. So now in present lecture we are going to discuss the same method only, but in the different manner. So therefore after getting the f of x system of equations, so we are converting that system into x is equal to something. Previously we discussed that x is equal to pi of x. Now here we are going to deriving that value as, so here you have minus 5y is equal to minus y square minus 4. Okay, and send that minus 5 to RHS, you will get y is equal to 1 by 5 into y square plus 4. Here also we are getting y is equal to something. Okay, next here we have x is equal to something from the second equation. Okay, so minus 10x is equal to, so that value where x is equal to 1 by 10 into 3y(x square) plus 7. Whenever we are going to use iteration method, the first thing you have to do is x is equal to phi of x, or x is equal to something, y is equal to something. So therefore here x is equal to f of x comma y. In this method we are going to take the RHS part as f of x comma y. Why? Because that equation exists in the two variables. Okay, x is equal to f of x comma y, therefore that is equal to 1 by 10 into 3y(x square) plus 7. That is taken as equation number 2. Next, y is equal to g of x comma y, capital G of x comma y. So therefore that is taken as 1 by 5 into y square plus 4. Okay, this equation we can take it as a g of x comma y. Now those two equations we are taking equation number 2 and equation number 3. After getting this condition, our aim is now we have to find out the convergence possibilities. Okay, conditions for convergence. So what are the conditions for convergence means? So we have to apply the partial derivative for equation 2 and equation 3 with respect to x and y. Why? Because their variables are x and y now. So therefore with respect to x and y we have to apply the partial derivative. Partial derivating equation 2 and 3 with respect to x and y, you will get, okay, so dou f by dou x, RHS part we are going to do the partial derivative of both equations. Dou f, okay, if you do the equation number 2, function is f of x comma y. Okay, that function first we are doing with respect to x. Okay, whenever doing that with respect to x, the total terms, remaining terms which are in terms of y and constant, those all become constant only. Only we are doing derivative for the only small x terms only. So therefore 1 by 10 into 3y into x square is nothing but 2x. If you write that value 6xy by 10, that is the partial derivative of f with respect to small x. Next, partial derivative of f with respect to y. Okay, so 1 by 10 into 3 into y is there, for y it is 1. Okay, therefore 3x square, so therefore 3x square by 10. That is the equation number 2, partial derivative with respect to xy. Now equation number 3, partial derivative dou g by dou x. There is no x term in equation number 3. There is no x term in equation number 3, therefore you can write equal to 0. Okay, for example, if you have x here, okay, then you will get the total value 1 by 5 into y square plus 4 as a constant value. If there is no x term, so then the total differentiation will become 0. Why? Because the total term you have to consider as a constant. Derivation of constant equal to 0. Next, dou z by dou y is equal to 1 by 5 into, okay, y square derivative is 2y plus 4 derivative is 0. So therefore 2y by 5 is the partial derivative. So now we got 4 partial derivatives of the equation 2 and equation number 3. Now let the initial approximation be 0.5 comma 0.5. In the original method only we have to consider the initial approximation. Okay, so in this method also we have to consider the initial approximation x0 comma y0 as 0.5 comma 0.5. Why? So actually root is x is equal to y, x is equal to 1, y is equal to 1. Okay, the initial approximation is less than actual root only. So therefore 0.5 comma 0.5. Now conditions for convergence. In the iteration method, definitely you have to prove the conditions for the convergence. So therefore what are the conditions means magnitude of the partial derivative with respect to x at x0 comma y0. Okay, so we have to prove that magnitude of the partial derivative at x0 comma y0 is less than 1. Okay, so you can see mod dou f by dou x plus dou f by dou y at x0 comma y0 is equal to, substitute the values, okay, corresponding values, and apply the values. Okay, therefore 6 into, here x is nothing but x0. Okay, whenever you apply, this will become x0 comma y0 and here x0 square. Okay, so therefore 6 into 0.5 comma 0.5 by 10 plus 3 into 0.5 whole square by 10. If you simplify those values, you will get 0.2250. It is also less than 1. So therefore magnitude of the given partial derivative at x0 comma y0 is less than 1. So that is the first condition, and second condition is magnitude of the capital G, same. So dou f by dou g by dou x at x0 comma y0 plus dou g by dou y at x naught comma y naught is equal to, this value will become 0 and this value will become 2y naught by 5. Okay, so therefore then you will get it is also 0.2, so it is also less than 1. Whenever you have the condition mod derivative is less than 1, then by iteration method, hence the conditions for convergence are satisfied. Okay, so then the approximations are given by, whenever condition for convergence exists, then we can go to the approximations. So what is the approximations? Approximations we can derive by the given equation only. We have derived that x is equal to f of x comma y na. With the help of this equation only we are writing x suffix n plus 1 is equal to 1 by 10 into 3 into y suffix n xn square plus 7. In the original iteration method also, whenever you derive x is equal to pi of x, after proving that convergence condition mod pi dash of x less than 1, so you can write xn plus 1 is equal to pi of xn only. Same condition here we are applying, x suffix n plus 1 is equal to f of x suffix n comma y suffix n. Okay, x suffix n plus 1 is equal to f of x suffix n comma y suffix n. Similarly, y of n suffix plus 1 is equal to capital G of x suffix n comma y suffix n gives the nth approximation in this method. So that is taken as, that system is taken as equation number 4. Okay, so now by using system of equation number 4, we are going to find out the approximations to get the convergence of the root is equal to 1. Okay, so first approximation, when start with n is equal to 0, substitute n is equal to 0 in equation number 4, you will get x1 is equal to 0.7375. Initial approximation is 0.5. Okay, so now you can see here, initial, actual our original root is 1, but we have taken initial approximation as 0.5. This is x naught. Originally x is equal to 1. Okay, next x1 we got 0.7. 0.7 as x1. So therefore y1 is 0.85. y1 is 0.85. That means for each and every approximation, the values which what we are getting x1, y1, x2, y2, those are gradually converging towards 1. You can observe carefully the second approximation, take n is equal to 1 in equation number 4. Okay, so then x suffix 1 plus 1 is equal to this equation. Then x suffix 2, if you substitute the values and simplify them, you will get x suffix 2 is equal to 0.8. Previously x suffix 1 is equal to 0.7. Now it is 0.8. Next to 0.9. Okay, nearly. So therefore, similarly y suffix 2 you will get 0.9. Next third approximation, n is equal to 2, you will get x3 is equal to 0.8993 and y suffix 3 is equal to 0.9784. Fourth approximation, for n is equal to 3 in equation number 4. So therefore then you will get x suffix 4 is equal to 0.9374. You have to continue this process until you get the approximation root very close to original root. Actual root is x is equal to 1. You have to continue this process until you get the approximation root is convergent very close to 1. So therefore y suffix 4 is equal to 0.9915. Fifth approximation, you will get x suffix 5 is equal to 0.96. 0.9 is there. 0.9 is very close to 1. So therefore y suffix 5 is equal to 0.9966. It is also very close. Next sixth approximation, we got x suffix 6 is equal to 0.97. It is also very near, and 0.99. Okay, and seventh approximation, x suffix 7 is equal to 0.9855. Okay, so and eighth approximation 0.9912. Y suffix is equal to 0.999. Exactly it is equal to 1. Okay, so now after completion of the 8 approximations, we can observe that by observing 7th and 8th approximations, that is x7 comma y7, you can see here x suffix 7 is 0.9855. Okay, and x suffix is 0.9763. 0.9898 means very close to 1, and y7 is also, you will have same values only. So therefore by observing both of them, those values are approximately same and towards converging to 1 comma 1. X values from we started with 0.5. Okay, we started with 0.5. gradually they are moving to converge 1. Same y value also we started with 0.1, gradually they are moving to 1. So therefore x comma y is equal to 1 comma 1 is the root. Okay, so therefore this is the total explanation of the method of iteration. Okay, what is the use of this method is actually by for any system of equation, by seeing only we can say that x is equal to 1, y is equal to 1 is the actual root. But by applying the method of iteration, also we can find that the approximation root also converges to the actually root by doing the regular process. So therefore, this is the method of iteration in non-linear variables. Okay, non-linear variables of equations. So these types of problems are very important for the long answer purpose in the examination. Okay, so make a perfect practice, prepare well. In the next lecture we are coming with another method. Okay, so until bye, thank you.